Hi guys, welcome to the Fluid Mechanics Lab. My name is Milad and today I'm going to take you through the pipe friction prac. The aims of this prac are first to investigate the relation between pressure drop across a smooth horizontal pipe with respect to the average velocity, and the second aim is to observe the transition from laminar to turbulent flow. I'll briefly first explain the theory. So this is the pipe that we have. It is horizontal. The inlet conditions are the inlet velocity U1, inlet static pressure P1, and inlet height Z1. And we have U2, P2, and Z2 for outlet conditions. So from Bernoulli equation, we have Z1 plus U1 squared over 2G plus P1 over rho G is equal to Z2 plus U2 squared over 2G plus P2 over rho G plus HL. And HL is a head loss due to friction factor. I can further simplify this equation. Because we have a horizontal pipe, we can get rid of Z1 and Z2, and because of continuity, U1 and U2 are equal. So you're left with P1 minus P2 over rho G that I call delta P is equal to HL. And this is equation 2. I also can write HL as a function of F, which is Darcy friction factor, L over D, and L and D are the length and diameter of the pipe respectively, times U squared over 2G. This is equation 3. If I introduce equation 2 into 3, I'll have F equals delta P over L times 2D over rho U squared. From this equation, I can see that F is a function of D, rho density, U velocity, and also because of delta P over L, we have viscosity involved. So from these four parameters, I can make Reynolds number, which is rho UD over viscosity. And this is equation 5. So equation 5 tells us that F friction factor is a function of Reynolds number. We know the exact relation between friction factor and Reynolds number in the laminar region, and that relation is F equals 64 over Reynolds number. And if I take logarithm from both sides, I have log of F is equal to log of 64 minus log of Reynolds number. And this first term, if I consider it as y, log of 64 is a constant, and log of Reynolds number as x. I can see that in a log-log scale, relation between friction factor and Reynolds number is a linear curve with a slope of -1. Now if I want to plot these relations on a F versus Reynolds number in a log-log scale, the laminar region is a linear curve with a slope -1, and this is what the turbulent region looks like. So this is lamina. The region in between is called transition, and turbulence. So what we do in the prac, we will have water flowing inside the pipe we can measure the velocity using flow meters. We also can measure the pressure drop, delta P. By having delta P and U, we can calculate Reynolds number and F. And we will have one experimental point on this plot. By changing the velocity and measuring velocity and pressure drop, we can have more points, more experimental points on this plot, and we are essentially going to reproduce friction factor versus Reynolds number curve in this prac.